Welcome to Module 16, Indoor Air Quality and Ventilation. In this module, we connect IAQ to practical BS decisions. The BAS can help us monitor ventilation, filtration, moisture, pressure, and trends. But it does not replace source control, inspection, or qualified professional judgment. The goal is to help you evaluate the whole IAQ strategy. What is in the air, how air moves, how it is cleaned, what sensors can and cannot prove, and what action should follow an alarm or complaint. These objectives are practical. After this module, you should be able to look at an IAQ complaint and avoid jumping to one sensor or one set point. You will evaluate sources, ventilation, filtration, moisture, pressure, and monitoring as a connected system. You will also learn why CO2 is useful but limited, and why every IAQ alarm needs a defined owner and response plan. This module moves from concept to practice. We begin with what IAQ means in the hierarchy of controls. Then we review ventilation, CO2, filtration, outdoor air quality, moisture, comfort, and monitoring. Finally, we apply the ideas to worked examples and an assignment. The field goal is simple: diagnose the right problem before applying the wrong BAS response. This visual summarizes the module. On the left is the IAQ control hierarchy. Start with source control whenever possible, then provide ventilation to dilute and remove contaminants. Use filtration and air cleaning for the target contaminant. Finally, monitor and respond so the building continues to operate as intended. On the right, the BAS elements include outdoor airflow, CO2, filter differential pressure, humidity, dew point, room pressure, and exhaust. The key message is that IAQ is a system outcome, not a single sensor value. Indoor air quality is not created by one device. It is the result of sources, pathways, exposure, and response. The BAS can help monitor conditions, coordinate airflow, trend alarms, and support decisions. But it cannot repair water intrusion, eliminate all pollutant sources, or make health conclusions beyond the evidence. A strong IAQ strategy starts by asking what source, pathway, or exposure we are trying to manage. The IAQ hierarchy helps us avoid weak solutions. If the problem is a source control is usually stronger than simply increasing ventilation. If ventilation is required, damper command alone is not proof of outdoor airflow. Filtration must match the contaminant and system capability. Monitoring is important, but it is the fourth layer, not the first solution. A sensor should help trigger the right response, not replace the response. Ventilation is the controlled introduction of outdoor air and the removal or dilution of contaminants. In BAS work, one of the most common mistakes is treating damper position as proof of outdoor airflow. It is not. Linkage, pressure, fan operation, economizer mode, and outdoor air path resistance all matter. A professional verifies the airflow or creates a credible estimate and then checks whether exhaust, return, relief, and building pressure are coordinated. CO2 is useful because it can show occupancy-related buildup and ventilation response. But CO2 is not a universal indoor air quality sensor. It does not directly measure particles, VOCs, moisture sources, mold, odors, or process-specific contaminants. Before making a demand control ventilation sequence more aggressive, verify sensor location, calibration, actual outdoor airflow, occupancy pattern, room mixing, and system delay. A slow CO2 decay may be normal for the room volume and ventilation rate. Filtration and air cleaning are powerful tools when they are matched to the target contaminant, and the system can support them. Higher efficiency filtration may improve particle removal, but it can also increase pressure drop. Review fan capability, energy impact, airflow, filter rack sealing, and bypass. Filter differential pressure is useful, but it does not prove filtration effectiveness by itself. Air can bypass a poorly sealed filter rack, and tubing or scaling problems can mislead the BAS. Outdoor air is essential for ventilation, but outdoor air is not always clean. Wildfire smoke, traffic, industrial activity, pollen, ozone, and weather events may require special operating strategies. Possible responses may include enhanced filtration, pollutant monitoring, controlled pressurization, temporary recirculation under approved conditions, and occupant communication. but any reduction in outdoor air must be approved and must respect life safety, code, process, and occupancy requirements. Moisture supports many IAQ problems. The BAS can help by monitoring humidity, dew point pressure, condensate alarms, coil conditions, and trends, but the BAS cannot repair a roof leak, dry wet materials, or fix a failed drain pan. When a room is at 72 degrees with high relative humidity, do not immediately lower the temperature set point. Review dew point, outdoor air and exhaust balance, infiltration, envelope leakage, doors, and coil leaving condition. Thermal comfort depends on more than air temperature. Mean radiant temperature, airspeed, humidity, clothing, activity level, location, and personal preference all affect complaints. A room sensor at set point does not prove comfort. BAS professional should investigate where the complaint occurs, how the space is used, whether surfaces are cold or warm, whether air distribution is appropriate, and whether humidity is part of the issue. A monitoring strategy should start with a decision, not with a sensor shopping list. Ask what decision will be made from the measurement. Will it change ventilation, trigger inspection, notify occupants, schedule maintenance, or confirm a trend? Then define sensor quality, alarm thresholds, response procedures, data retention, and who owns the alarm. Without response procedures, IAQ monitoring can create fear instead of action. These examples show how to think. A slow CO2 response may not mean the PID loop is wrong. It may reflect room volume, mixing, and ventilation rate. A low filter differential pressure may not mean the filters are fine. It may be bypass or bad tubing. A high humidity complaint may not be solved by lowering the temperature set point. The moisture pathway may be infiltration caused by pressure imbalance. Use the data to decide what evidence to verify next. The correct answer is C. Acceptable CO2 does not prove that all indoor air quality concerns are resolved. CO2 mainly supports occupancy-related ventilation assessment. A musty odor after rain suggests a possible moisture source, damp material, or building envelope pathway. The professional response is to investigate moisture, pressure, filtration, source control, and whether the monitoring strategy is appropriate for the actual complaint. For the assignment, select one real or sample area and create an IAQ monitoring and response plan. Do not begin with the sensor. Begin with the source and pathway questions. What activities occur there? What outdoor air is required? How is outdoor air verified? Are exhaust and pressure relationships coordinated? What filtration is installed and is it sealed? Is moisture or condensation possible? Then define what the BAS should monitor, what alarms mean, who responds, and what evidence closes the issue. The takeaway is that IAQ is created by sources, airflow, filtration, moisture control, operation, and people.